Okay, we're recording. So, we're going to start talking about data analysis and statistics. So, mostly what you've done until now is learning MATLAB, right? You're learning programming. And some of the things maybe we had you do little games and stuff you might have thought were a little pointless. And the reason was just to focus on the programming side. Now we're going to use that programming to do real things that you might do as an engineer. So hopefully a lot of these topics are somewhat familiar from your math class. But we'll cover them, and then now you'll get a lot of chances to practice, for loops and functions and all these things that you've been learning. So if you're rusty on anything that we've covered, you should come get help because you're going to need that now in other circumstances. So what is data analysis and statistics? Statistics is the study, collection, organization, analysis, interpretation, and presentation of data. So, collecting data is often the straightforward part, right? You go into a lab, maybe you have to set up a complicated thing, or maybe it's pretty easy to get data. If you're taking temperature data, pretty straightforward. The difficult part is how do you find a story and tell a story about that data? And this is can be an art form, right? So take the example of calculating the average of something, right? You can choose the mean, the median, or the mode. Those are all different ways to calculate the average or central tendency. But what if there's outliers? There's a couple that are really big or a couple that are really little. When you're presenting the data to someone, you need to decide, well, do I include those outliers in my average or I don't? And how you include those or don't are going to affect your answer or your presentation or your story. And so it is kind of an art form. You have to kind of think about what story you're trying to tell and how do you do that from the data. So these are all the different statistical measurements we're going to be talking about. So we're going to talk about the statistical measurement, then what's the definition? What does it measure? And what is the MATLAB code or the MATLAB function? So the first one is mean, which you've used, hopefully. So this is, the definition is the mean is equal to So the mean is just the sum divided by the number of elements, and it measures the central tendency. And it's mean of x, where x is our data. So now we have median, which is just the middle number. Same thing, it measures the same thing, and it's simply median. Then you have the mode, which is the most frequent. Measures the same central tendency, mode of x. So now we get into standard deviation, which you haven't used yet in this course, standard deviation. So this is measuring basically the variation or spread from the mean. Where x bar is the mean, calculated above. So this measures the variation or spread in your data. And this is STD of x for standard deviation. So then from the standard deviation, you have the variance, which is going to be the squared. And it measures the same thing, and this is VAR in MATLAB. And then we have the covariance. Sigma, those are sigmas. So what does this measure? My columns are getting messed up a little bit. So this measures basically the strength of correlation between two data sets. So are they correlated? You know, as one goes up, does the other one go up? We'll talk more about correlation in a second. And this is in MATLAB, COV. And then one last thing, the correlation coefficient. Okay, so we're going to be, you've already seen mean, median, and mode pretty well. We're going to focus on these last ones here for now. So in MATLAB, the covariance and the correlation coefficient, if you type those into MATLAB, it's going to give you a matrix of 4 things. So for example, if we typed in sigma of xy equals the covariance of a data set x and a data set y, we would get out that sigma xy equals a 2 by 2 and so if you're looking for sigma xy, then you'd have to take the first row, second column to get that. And then the same thing with the correlation coefficient. So when we are talking about correlations, is that okay? Did I go too far? Okay, so you can have a positive correlation or a negative correlation. So let's look at, first of all, the correlation coefficient R is going to be between -1 and +1. So what does a perfect positive correlation look like? So if you have a set of y and a set of x, it's going to look like this. This is your R equals 1. Perfect positive correlation. Now, when you start getting a bit of spread in your data, so let's say, it still looks like it's trending upwards, but now there's a bit more spread. This is going to be maybe more like an R equals 0.8. So it's going to be a high positive correlation. And then finally, you can have even more spread than that. And it still looks like it's trending upwards, but maybe your correlation coefficient is down to 0.3. So this is going to be a low positive correlation. So then we've gotten to 0. So what does 0 look like? Correlation coefficient of 0 is just going to be random nonsense. There's no correlation whatsoever. And now we can do these same ones with a negative. So what does a negative correlation look like? It's just a negative slope in your line. So this is going to be a perfect negative of r equals -1 now. And then if we had r equals -0.8, r equals -0.3, you can probably fill those in. Same thing, they're just going to be trending downwards instead of trending upwards. So correlation, how does, question, yeah?
Does it always have to be linear?
A correlation, yes. So if you had a nonlinear correlation, that would be not calculated with the correlation coefficient. So correlation, we have positive and negative, strong versus weak. So let's say, you might hear a lot of times, correlation does not mean causation. So just because they're correlated does not mean that one causes the other. So you have a couple different options. One, you could have X cause Y. Let's say there's a strong positive correlation. You could have Y cause X. You could have X and Y both caused by some other factor Z, or it could just be a coincidence. Maybe they aren't correlated at all. So if you think about age versus height, okay? So age is correlated to height, right? But at what point, right? So if you look at the ages like 0 to 20, age is positively correlated to height, right? Then if you look at the age maybe like 20 to 70, is age correlated to height? No, probably not. But then if you get to maybe 70 to 100, age is correlated to height again, and now it's negatively correlated. And so then you think about this, well, does age cause height? Yes, so you would say yes, probably for, less than 20 or greater than 70. But let's look at another example. So let's say you had data that was the number of homeless people, and then you had another set of data which was the number of crimes, and let's say this is by city. So it might be true that where there's a lot of crimes, there's a lot of homeless people. But does that mean that having more homeless people cause crimes, or having a lot of crime causes more homeless people? Not necessarily, right? You can't make that determination just from the correlation coefficient. It could be that something else causes both of those, like perhaps unemployment or drug use were my examples. Or maybe it's just a coincidence. So that's correlation. Remember that it does not cause causation. So now I think we are ready for our example. Whew, we're moving fast. Okay, so this is directly helpful for your programming assignment 9. So what we're going to do is, okay, so here was the formula for standard deviation. We are going to start this. I'm not going to do the whole thing for you, because if I did the whole thing for you, you have to calculate the correlation coefficient in your program assignment. So if I did this whole thing for you, then all you'd have to do is call it twice down here. So we'll start it, and then you can finish it for your programming assignment. So we're going to start by thinking about the steps, or the human steps, how we'd go about this. So our goal is to write a standard deviation function. But we can't use any of MATLAB intrinsic functions, right? We can't just type std of x. We can't use mean, we can't use sum. So we're going to figure out how do we do all this with MATLAB programming logic. So recall the formula, sigma x equals square root 1 over n minus 1. The sum of I equals 1 to n of xi minus x bar squared. Okay, so first step, any thoughts? Here we have the mean, where x bar is equal to 1 over n the sum of xi. So we'll start by calculating the mean, right? Because that is in there. We need to know that. So step 1, I'm going to say calculate the mean. So how do we do this? What are the steps involved in that? Well, you see there's a sum, right? So we need to sum basically the x values. And what are we summing them over? From I equals 1 to I equals n. So does anyone have any thoughts on what a great way to do that would be? A for loop. Okay, so we'll come back to that. So step 2, once we have the mean, after we've calculated this mean here, what do we have to do next? What would be the second step? Any thoughts?
Is square root an intrinsic function?
It is, but you could do like to the 0.5 power. Yeah. Okay, so we need to do another sum, right? So we need a sum. We'll do, how about xi minus x bar squared. Okay, and again, we're going to do from I equals 1 to I equals n. So we'll keep this note here. Maybe we'd use a for loop again. And so now, the step 3, as we want to calculate sigma x, and we should have all the parts ready, that we can just write it out. So okay, we're going to take 5 minutes, and I want you to take these 3 steps and try and write out this code on a piece of paper in front of you. You can talk to your neighbor, ask questions. In 5 minutes, we'll check back in, and I'll start going through the steps with you.